A very good morning to you all. So during our previous lectures, we managed to discuss with respect to Introduction to Computer Forensics, searching and seizing with a warrant, and searching and seizing without a warrant. We went a step further to describe what digital evidence is. But however, today, we're going to move a step further and discuss what data acquisition is all about. So when we were talking about the incident response methodology, we say the incident response methodology is a 7-step methodology, and we went through the various processes or what actually happens during each stage of the incident response methodology. And we said during the investigation phase, or when one is performing an investigation, there are two processes that are involved. The first process is data acquisition or data collection, and then the next process is data analysis. So since we are doing a module in computer forensics, tools and techniques, it's imperative for us to have a clear understanding or an appreciation of what transpires or what data acquisition is. So when you look at the words data acquisition, we basically have two words. Data acquisition is a combination of two words, data and acquisition, of which we described data as raw facts and figures. For example, someone might say 1 is data. But however, information is processed data that has meaning and can be used for decision-making purposes. So, in computer forensics, the way data and information might be used interchangeably, or the words data and information might be used to refer to the same thing. And when we talk about acquisition, we're simply saying, how do we collect or how do we obtain digital evidence? So we're going to be discussing with respect to data acquisition. But however, for this particular module, when we talk about data acquisition, we're going to be looking at the Windows operating system as a case study or as a field or an area in which we're going to be conducting our computer forensics. So now, during data acquisition can be done to volatile data or non-volatile data. So we're going to first of all start by how one can actually collect data or information on volatile data in Windows systems. So you will discover that as we move on, we are going to perform a live data collection from a Windows system. Basically, when we say live data collection, we're basically saying we're going to try and acquire data or information from a Windows system that is currently switched on. Some of the reasons why as forensic investigators we ought to perform live data collection is that in the event that a machine actually switches off as an investigator, there are certain pieces of information that will be lost in the event that a machine is turned off or is switched off. So, when you're performing your investigation, when an incident has been reported, it is very, very imperative, or it is important for you to perform what we call a live data collection. And in order for us to perform a live data collection, we'll need what we call an IRA toolkit, or an initial response toolkit. As the lecture is going to progress, or at the end of this lecture, I'm going to show you how you can create an IRA toolkit. So, some of you might be asking, what kind of data would you collect from a Windows system that will be very, very difficult for an investigator to obtain in the event that a machine is switched off, or is powered off, or the machine switches off because of lack of power? So, basically, when you're performing data collection from a Windows system, the first thing that you need to capture or to collect is the time of the incident, or the time on which the investigation has actually started. But however, let's say for instance, you might collect or you might start an investigation at a particular time, for instance 8 a.m. But however, to zero in or to give a specific or a clear indication of when and where the incident took place, you also need to collect the date. So, when you start your investigation process during data collection of a live Windows system, you need to collect the time and the date. And in order for you to collect the time or the date, there are certain commands that you use to collect such information, or to collect such data. Also, when you're performing data collection from a Windows system, you also need to know the users that are currently logged on to a particular system. So, from your Windows system, you need to know the users who are currently logged on. And in order for you to know which users are currently logged on to a particular system, you use a command known as ps logged on. Some of you might be asking, why is it important for us to know the users who are currently logged on? You will discover that depending with the sizes or with the nature of organizations, different organizations have various IT policies, different organizations have different security policies, different organizations have different computer usage policies. So you might discover that in some organization, you might have two or more people using a particular machine or a particular system. So when an incident is reported, you need to know the user who is currently logged on to the system, as a way of trying to identify the perpetrator of a particular crime, or the perpetrator of a particular incident. We also have commands such as fport. Like, for instance, when a hacker or when an attacker tries to gain access to a system. The attacker or the hacker makes or listens to the ports that actually open on a particular machine. And it's through those ports you will discover that there are common ports that are used by hackers. So, as a way of us to try and obtain valuable data during the investigation process, we also need to make use of the command F port. We also have PS list. PS list is a command that is used to obtain the processes that are currently running on a particular system, or the processes that are currently running on a particular machine. Why is it important for us to know the processes that are currently running on a particular system? Let me start by saying the process or the application that are running on a particular machine. Let me start by saying this. If you're a system administrator or if you're a network administrator, there are certain processes that you evoke, that you, or when a Windows operating system is booting, or when it has finished the booting process, there are certain processes that are supposed to run on that particular system. So as an investigator, those processes are actually known. If you're an investigator, you know such processes. So having a list of all the running processes will help the investigator in the event, let's say for instance, an attacker is using, let's say, a Trojan horse, or an attacker is making use of malicious software to gain your system. Through that list, an investigator can actually pinpoint the process that is being used to penetrate a particular system. So, this diagram on the presentation is simply stating how one can use Netcat during initial response to incidents. And we're saying when this process is being done from the anti-system into the forensic system, the first thing that you need to do is you need to run what we call trusted commands on an empty server or on an empty system. An empty server or an empty system, in this particular case, it's representing the Windows system, which is making use of the new technology system. Then the second thing that you ought to do is you need to send the output to the forensic box via Netcat. So the system that is collecting data from a Windows system is the Netcat. Then the third thing that you also ought to do is to perform offline review of MD5 SAM output files. Some of you might be asking, why do we use MD5 SAM or MD5 checksum? The purposes of using a hash function or a hash algorithm during data collection of a live system is for us to be in a better position to prove that the investigation process, or to prove that during the investigation process we have not altered or tampered around with the evidence. So you will discover that usually when we collect the system date or time when we start the investigation process, the second thing that we need to do, or the third thing that we need to do, is we need to perform an MD5 SAM, or we need to perform a checksum, whereby we are getting all the hash values of the initial response toolkit. So basically, the diagram on the PowerPoint presentation simply highlights how data is collected from a Windows system using Netcat. Now, when I was explaining how one can actually collect data using Netcat from a Windows system, I was also explaining with relation to how one can actually obtain volatile data. So, on obtaining volatile data, like how we explained it during when we were discussing with respect to the characteristics of digital evidence, and we said we can have what we call volatile data. Volatile data can be said to be perishable data, or data that is actually lost in the event that power on a particular machine or in a particular system is actually switched off. Once a machine switches off due to maybe lack of power from the power source or due to maybe a power outage, you know, there are certain pieces of data or certain pieces of information that an investigator might not recover. So it is important for us to create an IARA toolkit as a way of collecting volatile data in a swift and in a forensically sound manner. So, when we are obtaining volatile data, we need to collect the system date and time. As I was explaining during the previous slide, the system date and time is important when you're obtaining volatile data. Why? Because it simply marks the start of the investigation. It simply marks the start on when we collected our data. Also, when obtaining volatile data, we need to know, or we need to have a list of the users who are currently logged on. The reasons why we need a list of the users who are currently logged on is, as an investigator, we need to actually pinpoint who was using the machine at a particular point in time. We also need time or date stamps for the entire file system. When we say we need time or date stamps for the entire file system, what we simply need to do is we want to collect the metadata of a particular file. Metadata simply means data about the data. There are things such as date and timestamps, last modified date, date last accessed. All these things are the data that emanates from the time or date stamps for the entire file system. So we're basically saying we also need the metadata of a particular file when we are obtaining volatile data. So during this process of collecting volatile data, we also need a list of currently running processes. So a list of all currently running processes will help the investigator to actually identify if there is a malicious process or if there is a malicious application that is running on a particular system when an incident it occurs or when an incident is occurring. We also need a list of currently open sockets. Like what I was saying, there are known sockets or ports that are actually known by an attacker or by an hacker. So these sockets, sometimes if they are open, they enable the system to be vulnerable or to be susceptible to attacks. So having a list of currently open sockets should be a goal for an investigator when he or she is trying to obtain volatile data. We also have the applications listening on open sockets. Usually, when a system or when a machine has or has been infected with a Trojan horse, basically a Trojan horse, an attacker might attach a particular email with the Trojan horse. So the purposes of this Trojan horse is such that if a user of a particular system evokes or opens a particular email attachment, that email attachment will create a backdoor on the machine. That backdoor will be used, or that backdoor or that trapdoor will be used by an attacker to gain access to our system. So, as an investigator, when you're obtaining volatile data, it is very, very important for you to know the applications that are actually listening on open sockets. Last but not least, when you're obtaining volatile data, you also need to know users or systems that are currently connected to the system, as well as if there are any remote connections that are present. And in order for you to achieve that, you can make use of various commands or various tools that we have in computer forensics. So, when collecting volatile data, there are certain steps or certain processes that you need to do. So the first step is you need to execute a trusted command prompt. So as we are going to be demonstrating, I'm going to show you where you can actually find a trusted command prompt. Then the second step is you need to record the system time and date. The third step is you need to determine who is logged into the system. The fourth step is you need to record modification, creation, and access times of all files. Determining open ports is very important when you're collecting volatile data. You also need to list applications associated with open ports. You also need a list of all running processes. The eighth step is you need a list of current and recent connection. You also need to record the system time and date. Some of you might be asking, when we executed a trusted command prompt, we then recorded the system time and date. And now before we finish the process of collecting volatile data, we also need to record the system time and date. Some of you might be wondering why we record the system time and date during the investigation or during the inception of the data collection, as well as recording the system date and time when we are about to finish the process of collecting data. The reason is the latter simply marks the end of the data collection of volatile data exercise. Then the last, when we are collecting, the last process when we're collecting volatile data is we need to document the commands used during initial response. So, usually there's a misconception that is there. Like for instance, in an organization, it is the duty or the responsibility of an investigator to know the types of operating system that a particular or that particular users use, to such an extent that if a particular organization is using, if all the machines on a particular organization are running on a Windows 8 operating system, if it's 32-bit, then an investigator needs to create an initial response for a Windows 8 32-bit machine. If it's a Windows 8 64-bit machine, when an investigator is going to a particular incident as an initial response or to perform an initial response, he or she needs to create or to go with the Windows 8 64-bit IR toolkit. What exactly am I saying? Basically, what I'm simply trying to say is, depending with the operating system that a particular machine is using, one has to carry or one has to go to perform or to collect volatile data using an IR toolkit that is specifically made for a particular Windows operating system, be it Windows 7, be it Windows XP, be it Windows 8, be it Windows 10, whether 32-bit or 64-bit. Because some of the processes, if you are going to go, let's say for instance, you're going to go with an IR toolkit for a Windows 32-bit, Windows 7 32-bit machine, and when you want to try to use that on a Windows 10 64-bit, that IR toolkit might fail to collect volatile data. So it is imperative to create an initial response toolkit that is that might be used for a specific type of Windows operating system that you are actually investigating. So, during the process of collecting volatile data, we said one should run a trusted command prompt. So basically, as a way of gathering these tools, they are, remember, in forensics, we said when one is performing forensics, one has to use forensically sound tools. You just don't use any other software to perform digital forensics. You need tools that have been tested and tools that can be that is actually undergone a particular process for them to be called forensic tools. But however, our Windows system, in order for us to collect volatile data, our Windows system has built-in commands that we can make use of, that we can actually use to gather or to collect data. Like for instance, the command prompt. We're basically saying the command prompt is usually built in all Windows operating systems. But however, if you want a utility that shows all users that are connected either locally or remotely, a tool that you can use is called PS Logged On. And if you want to obtain that tool, you can download it from a website known as foundstone.com. We also have a command that shows which users have remote access privileges on the targeted system. A place where you can get such a tool known as RAS users, in order for you to be able to see which users have remote access privileges on the target system. You can get that on the NT resource kit. We also have a command known as netstat. Netstat is a tool that usually enumerates all the listening ports and all the current connections to those ports. And netstat is a Windows built-in command. To know all the processes that are opened in any TCP/IP ports on a Windows system, you make use of the fport tool. So this tool can be obtained on the website foundstone.com. If you want to know, or if you want to have a list of all the running processes on the target system, there is a tool known as PS List, and this tool can also be obtained on foundstone.com. We also have a utility that lists all the running processes, their command line arguments, and the dynamically linked libraries known as DLLs on which each process depends. We have a tool known as list DLLs and is found on foundstone.com. We also have other tools such as NBTstat, which shows the recent NetBIOS connections for approximately the last 10 minutes. And NBTstat is a built-in command. We also have ARP, which is also a built-in command, and is basically a system tool that shows the MAC addresses of the system that the target system has been communicating with within the last minute. We have tools such as kill, which terminates a process and is found on the NT resource kit or the NTRK. We also have the MD5 sum, which is a utility that usually creates MD5 hashes for a given file, and you can obtain that tool on the website cygwin.com. We also have tools such as Netcat. We also have tools such as CryptCat. We also have tools such as PS Log Lists, IPconfig, PS Info, PS File, PS Service, Audit Pool, as well as Dosky. Let me try and explain a little bit on Dosky. So basically, DOS key is a built-in Windows command tool or command that you can use to actually display all the command history for an open command prompt shell. So when you type DOS key as a tool, or when you use DOS key as a tool, it will actually list all the commands that were used by the investigator during the data collection exercise or during the live data collection process. So DOS key is very, very important. That's why you discover that when we were discussing with respect to collecting volatile data, we mentioned at the end that you also need to record all the tools or commands that you were using during the investigation process. So to obtain that, you need to use the DOS key command. So if you look closely to this on the slide, we're basically using PS logged on to list users that are currently logged on to a system. And all this is being done on a trusted command prompt or in a trusted command executable. So during the first instance, when the investigator typed logged on, the results were that there is a user known as Batman who is actually logged on locally, and there is no one who is logged on via resource shares. But when the investigator ran the instance the second time around, or when the investigator typed in logged on the second instance, we've actually seen that the current user of that machine is Batman, but on users logged on via resource shares, we have a user known as Doc. So when you're an investigator, let's say for instance, you have an authorized user known as Batman who is supposed to be using a particular machine within an organization. Let's say for instance, the person known as Doc is not an authorized user. So basically, when such information is presented to you, you will actually discover that maybe Doc is an unauthorized user. So if a particular incident occurred during a particular time, then maybe it might not be Batman who was using that machine. Doc was also using that machine, and Doc is an unknown user. So Doc might be the perpetrator of a particular incident of a particular crime. On the screen, we're basically saying when one uses NetStat to view current connection and listening ports on a trusted command prompt, basically NetStat will show you all the active connections that are there. It will list the protocol, if it's a TCP or if it's UDP. It will also show you the local address, the foreign address, as well as the state. Is that particular address, is it listening or is it established? So NetStat will simply show us all the current connection and the ports that are actually listening at that particular point in time. As we have highlighted earlier on, you can also use FPOT to view listening services. The only difference between FPOT and NetStat is that NetStat is built-in, is a built-in command on a Windows system. But however, to view listening services, you can also make use of FPOT, which we said you can obtain this tool on a website known as foundstone.com. So when you use FPOT, FPOT will show you the process ID, the processes, the port, the protocol, as well as the path of a particular process ID. So, when you're creating an initial response toolkit, you need to create a script such that when you put your IR toolkit on a target media, when you put your IR toolkit on a target media, all the volatile information or all the volatile data is collected within an instance within some few minutes. Like when you're collecting volatile data, this process or this task does not necessarily have to take the whole day. Basically, this process needs to be done quickly and swiftly, and the information that is collected should be collected at ease and in a fast manner. So, an investigator needs to script or to create a script of an IR toolkit. So a script can be written as follows, whereby you have time /t dead /t ps logged on dir that netstat -an fport ps list nbt start with an argument c time /t dead /d and DOSKey /history. So this is an example of how one can script the initial response. We are going to be running all these commands when we are doing or when we are performing our demo, that is tomorrow. So tomorrow we're going to be creating our IR toolkit, and I hope tomorrow all of you will be having computers that are running on Windows operating system, and I hope all of you will be having flash drives or flash disks that you actually use to create our IR toolkits. So, when we are collecting volatile data, as an investigator, you would need to create and use what we call an IR toolkit. When we are creating or when we are collecting volatile data, as an investigator, you need what we call an IR toolkit. But however, you will discover that when investigating, you also need to collect non-volatile data. The reason why we collect data is for us to be in a better position to actually analyze the data in order to come up with evidence that can be admissible in the court of law. So, to collect non-volatile data, we need to perform what we call a forensic duplicate. So, a forensic duplicate can be admissible evidence or can be used in the court of law. Or how can a forensic duplicate be an admissible evidence? In order to answer this, we need to ask ourselves this information, and I want you guys to go and find out these 2 or 3 questions that I'm going to be presenting or that I'm going to be asking. How does a tool become a forensic tool? How does a tool become a forensic tool? Remember, when we are talking about collecting volatile data, we describe various tools that you can actually use to collect volatile data. And we did mention that some of those tools, they are built-in Windows, they're built-in commands or tools within our Windows operating system. But however, some tools, we did mention that they can be found on the website foundstone.com or NTRK or Cygwin, only to mention a few. So I want you now to go and find out how a tool becomes a forensic tool. I also want you to find out what's the eligibility of evidence. I also want you to find out what's the eligibility of evidence. So now, when we're talking about digital evidence, we did mention what we call the best evidence rule. And we're basically saying a forensic duplicate can be made to be admissible evidence in the event that we follow the best evidence rule. And we said, if data are stored by a computer or a similar device, any printout or other output readable by sight shown to reflect the data accurately is an original. And we're basically saying, what does it take for a duplicate to be admissible? We're basically saying a duplicate is admissible to the same extent as an original, unless if a genuine question is raised to the authenticity of the original, or in the circumstances it will be unfair to admit the duplicate in lieu of the original. So the best evidence rule simply states that in order for evidence cannot be admissible in the court of law. A duplicate cannot be admissible in the court of law if the original evidence exists. A duplicate can only be admissible in the event that an original might not be carried or brought to the court of law, or in the event that a duplicate has been qualified. So, some of you might be asking, what is a forensic duplicate? So, a forensic duplicate is a file that contains every bit of information from the source in a raw bit stream format. We're basically saying a forensic duplicate is a file that actually contains every bit of information from the source in a raw bit stream format. What are we saying? We're saying a forensic duplicate is a file that contains every bit of information from the source in a raw bit stream format, whereby we are saying a 5 GB hard drive would result in a 5 GB forensic duplicate. And in order for us to create a forensic duplicate, we can make use of the DD command, or we can use the US Department of Defense, DoD, Computer Forensic Lab version of the DD command called the DCF-LDD. Another tool that you can use to create a forensic duplicate is an open data duplicator. You can also make use of tools or open source tools such as Autops, or you can make use of open source tools such as the FTK Imager in order for you to actually create a forensic duplicate. We also have what we call a qualified forensic duplicate. So basically, a qualified forensic duplicate is a file that contains every bit of information from the source. But however, this time it's not in a raw bit stream format, but maybe stored in an altered form. And we're basically saying there are two examples of altered forms. We have what we call in-band hashes, and we have what we call empty sector compression. So there are various tools that you can actually use to create a qualified forensic duplicate. You can use tools such as SafeBack, or you can use some of the tools such as EnCase, in which these tools are commercial tools. In computer forensics, we have what we call a restored image. So, a restored image is what you get when you restore a forensic duplicate or a qualified forensic duplicate to another storage medium. The moment we create or the moment we restore a forensic duplicate or a qualified forensic duplicate to another storage medium, this is what we call a restored image. We're basically saying one method involves a blind sector-to-sector copy of the duplicate file to the destination hard drive. If you restore the forensic duplicate of a 2.1 GB drive to a 20 GB drive, for example, the geometries do not match, the partition that started on the cylinder 20, head 3, and sector 0 on the original drive may actually start on the cylinder 2, head 9, and sector 0. So it means we have what we call a drive overlay software. So a drive overlay software, it is a third-party program that is needed when the BIOS of a computer's motherboard does not support the hard disks if they are larger than 528 MB. So in order for you to create a restored image, you can make use of SafeBack, MCAS, and any other uh, uh, freeware forensic softwares or tools that are present. Mirror image. A mirror image is created from hardware that does a bit for bit copy from one hard drive to another. We were basically saying most hardware duplicators are relatively simple to set up and operate. So two such duplicators are with what we call the LogicCube Forensic SF5000 and the Intelligent Computer Solutions ImageMaster Solo 2 Professional Plus. So, forensic duplication, two requirements. Forensic duplication, two requirements. We're basically saying the tool must create a forensic duplicate or a mirror image of the original storage medium. The tool must also handle read errors in a robust and graceful manner. If a process fails after repeated attempts, the error is noted. A placeholder may be put in the output file with the same dimension as the portion of the input with errors. The tool must not make any changes to the source medium, and the tool must have the ability to be held up to scientific and peer review. Results must be repeatable and verifiable by a third party if necessary. These are some of the uh, requirements for a forensic duplication tool. If a tool is going to modify or tamper around with the integrity of a particular file, then that tool cannot be a forensic duplication tool. So, on the screen, it's simply showing us how one can create a forensic duplicate of a hard drive, duplicating using the DD command or duplicating using the DCFLDD. So this is just for you to have an appreciation of how you can create a forensic duplication on a hard drive using the data duplicator or the Department of Defense of America DCFLDD. So if you want to know more of this, you can read further. But I just wanted to show you that you can create a forensic duplicate of a hard drive using a script such as the one on the screen. So likewise, this is a continuation of how you can actually create a forensic duplicate using that script. So when you're duplicating with the Open Data Duplicator or the ODDD, basically what we're saying is this tool follows a model that we call a client-server model that actually allows the investigator to perform forensic duplication on a number of computer systems simultaneously over a local area network. And it also includes modules or plugins that will calculate checksums and hashes, and it also performs string searches and extract files based on the file headers. So when you're creating a qualified forensic duplicate with SafeBack, on the initial startup screen for SafeBack, it basically offers 4 modes of operation. There is the backup function, the restore function, the verify function, and the copy function. So on the backup function, it simply produces a forensically sound image of the source media. Then the restore function restores forensically sound image files. The verify function verifies the checksum values within an image file. Then the copy function performs the backup and restore operations in one action. So basically, those are the 4 modes that you should expect to find when you're using SafeBack to create a qualified forensic duplicate.